All right, everyone, let's go ahead and get started. Greetings. I know it's morning for some, afternoon for others, and grueling late night for a few people. This is the DPRIVE session for IETF 110. Your glorious hosts for the day are myself, Brian, and my sidekick, Tim. So first thing we want to do is do a quick check on all the logistics. Eric is our continuing area director, so he gets to keep an eye on us for another couple of years, probably much to his chagrin. Jabber Room, if you're not actually following along in Meet Echo, is dprive@ietf.jabber.org. The only thing I would ask for a Jabber scribe today is if there are people who are actually following along just in Jabber without audio, if there was somebody willing to channel any mic comments that they want to make. Tim will try and keep an eye on the Jabber Room just to double check, but if there are people who are willing to do that relay, I would appreciate it. And the minutes are going to be kept in the CodeEMD site, so the link is there. Tim is going to keep track of the major action items if people want to follow along in the minutes and correct whatever typing errors he has, because I'm not sure if he got his requisite level of caffeine yet for the day.
Yeah.
Before we get too far along, the inglorious note well, just remember that these are the rules that you agreed to when you signed up for the meeting and are participating in the IETF. I will state that some of the BCPs at the bottom there are probably the best material you could read if you are having problems with insomnia. Agenda, we'll do a quick check to see if there are any updates that we want to make beforehand. Blue sheets will be collected automatically via Meet Echo. We'll start with some updates of older current work, move into some of the current working group business and new working group business. And you'll notice that we did not keep them completely separate because we wanted to intermix a couple of presentations to keep them adjacent to one another for coherency's sake. Information on the materials that we're working on are in the data tracker. If you have the materials downloaded, you can simply click on the link and it'll take you to the magical location for DPRIVE. The one thing that I'll bring up as a part of keeping track of what the working group is doing, we did get a revision of 7626 biz tightened down. It was not able to get submitted for official publication, but we do have a link sent to Alyssa, who is the sole discuss holder on that. So we're hoping she'll be able to review it and agree that the changes that we made address her concerns. So within the next couple of hours, we're going to talk about DNS over QUIC, and we'll talk about Oblivious DNS over HTTPS as the kind of the first block of time for the meeting. And then the second hour of the meeting will be more towards discussing the more general DNS authoritative encryption discussion. So this will include the document that we just recently adopted that Paul and Peter have been authoring. And then we also have a new document that Ecker and a few other people have put together that they wanted to compare against the Paul and Peter's draft. So those are our 4 discussion topics for the day. Anybody have any updates, changes, modifications they'd like to make? And I think this would be the point where I'd like to poke Scott Hollenbeck, if he's online, to raise the question that he had for us in the email.
Scott, this is Paul Hoffman. I believe you can just like unmute yourself and talk.
Okay, Brian, this is Scott Hollenbeck. Sorry, I tried to enter the queue in there, but didn't see anyone get recognized. Anyway, so just a quick question. If we're going to be talking about the solution drafts, and that's what I'll call the two that are up here on the slide, could we also have a quick update on where things are with the requirements draft?
Sure. So one of the things that we noted during IETF 109 was there seemed to be some discrepancies in some of the statements that were in the requirements document, and for the most part, the authors were trying to incorporate things that they thought were important, and they weren't getting a whole lot of feedback from the working group, as best I could tell. I would encourage people who have topics that they would like to make sure get addressed within the requirements document, bring those up on the mailing list, and we can actually have that discussion, because I know that there are going to be needs for those requirements in order for us to do anything useful with these two documents that are sitting on the agenda list right now. So I believe Benno, as one of the co-authors of the requirements document, did chime in that he was going to have time to work on this. I hope that there are discussions on the mailing list that actually help iron out that document, because I agree with you, Scott. I don't think that there are ways that we can make a definitive statement as to which one of these, if either of them, are going to solve the problem that we're trying to address here. Benno, did you want to say anything from the co-author side?
Yeah. Okay. Thank you. Yeah. Well, yes and no. I want to chime in indeed. So I'm more than happy to work with the working group on this requirements document, and indeed incorporate the recent discussion, or the discussion at IETF 109 and on the mailing list. But also indeed, so for, I think, one step back, I also would like to hear from the working group how useful this document is indeed. So I'm happy to work and spend time on this, but also I know Scott and some others really value this document as it gives direction, but also, as Scott remarks, well, if this document is not being updated and other drafts are being developed, so what's the use of this draft, of the requirements draft? And if the working group at large agrees that this is very useful also in making progress and give direction to other work items, I'm really more than happy to work on this. But I would like to make one step back and ask the working group: is this useful document? Do we want to have this document? I know that the chairs like this document. I know that some individuals, including myself, think it's a useful document. Yeah, what's the working group at large thinking about this document?
Yeah, that's a good point, Ben. We're not expecting the authors to do this lift on their own, because that's not going to accomplish what we need here.
Yeah.
So what I'll do is I'll ask Tim to actually put an action item on our list for the chairs to actually solicit the mailing list to raise any points or comments that they have on the current instantiation of the requirements document, so that we can come up with a set of concrete recommendations for the authors.
Yeah. Okay. Thanks. Yeah, I see a lot of +1 on the Jabber, so that's good. Thank you.
Cool.
Thanks,
Benno, and thanks, Scott, for bringing this up, because that is a document that we need to keep moving in order for us to understand what it is we're trying to do.
Yeah. Thank you.
All right. Any other comments or suggestions, changes for the agenda before we get started?
Looks like you have Paul and Peter in the queue. So Paul, do you want to start?
Sure. Just two things. One is I wanted to emphasize something. Brian, you said that we need the requirements document to know which problem we're working on. it's really clear that there are at least two problems that we're working on. And one of the issues with the current version of the requirements document is it's trying to shoehorn things into one. But I think from the mailing list, it's very clear. Some people care about opportunistic, some people care about fully authenticated. So as long as the requirements document can cover more than one, that would be great. And quite frankly, I think it would be lovely if we had the requirements document. We could then, if there's one or multiple documents that are solution documents, they don't have to cover what is the use case. They can point to the use case document. Thank you.
Thanks, Paul.
Hi, this is Peter. As I mentioned to Benno, maybe privately a long time ago, to me, a requirement document is not necessarily a full list of requirements that all have to be met, but it definitely is a list of things to judge a solution by. And this fits in with what Paul said. There's a lot in the solution space. We probably have two distinct but somewhat overlapping problems and solutions going with those. So maybe requirements is too strong a word. But regardless of what you call it, I do like having such a document. Thanks.
Thank you, Peter. Yeah, I agree that requirements documents are kind of the common terminology for things like that. But there are other ways of thinking about what we list in those documents. So I think this is an important discussion point for the mailing list, and we need to make sure that we're all in agreement on what's going in there. Okay, if there are no other comments on that, then I believe Sarah is up to talk about DNS Quick.
Okay, just checking audio again. Yeah.
Do that. Yeah. I suppose you want to go back to slide 1 for some reason.
It'll help.
Yeah, okay. All right, all yours, Sarah.
Okay, thank you. So this is an update on the status of the DNS over Quick specification. Next slide, please. So a little bit of potted history. I was quite surprised when I looked at the data tracker that it's now 4 years since we first proposed DNS over Quick. At that time, the draft actually went into the Quick working group. There was some interest at that time. A couple of years later, there was a bit of work in the hackathon, and this time last year, the draft was actually moved into DPRIVE and then adopted in April 2020. Next slide, please. So more recently, there was a presentation at the last IETF on the status of the draft, and coming out of that, I think it's fair to say that there was still some uncertainty on the exact direction that the working group wanted to take this draft in. The original version was specified only for stub to recursive. There were some questions around, is it still needed, given that we have 2 protocols standardized for that path, and questions around its performance. We were also asked to consider extending the draft. We were asked to think what it would take to extend it to cover recursive to authoritative, and in particular XFR, and the latest version of the draft begins to talk about that. A month after that presentation, AdGuard actually launched the first DNS over Quick Resolver service, which has been running since then, and they've given some presentations on that service. 2 related developments last month. One is that the core documents describing the Quick protocol are now in the RFC editor queue, so that's going to be published very soon. And last month, the ZOP draft also passed working group last call, so we now have a specification for encrypted zone transfers on the way. Next slide, please. So we did an update to the draft last month, and there were 4 main changes to the draft content. The first one was that we added an implementation section, and I've got a slide on that shortly. The second was that we added an appendix trying to address the XFR question. Again, I've got a slide on that. One other thing that happened after some discussions with Paul Hoffman was that the very early versions of the draft had suggested using port 784 for experimental implementations, but we now think it makes more sense to go ahead with a port request for port 8853, which is available. So it would be good to get some feedback on what the group thinks about that. I think possibly, given some of the discussions, it might be a little bit early to move ahead with that, but it's a proposal for the future. And there were some minor updates related to transport parameters based on some interop work. Next slide, please. Okay, so this is a quick summary of the current implementation status. We've got several implementations. The first 4 of these here came from the AdGod folks, who have wonderfully open sourced all their implementations that they're using for their stub to recursive service. So some are in Go, they've got some C++ libraries, there's a couple of basic implementations, and there's also an experimental implementation of Flamethrower. So we do have a few code bases that we can play with. Next slide, please. What we don't have yet, to my knowledge, is any rigorous performance measurements of Quick compared to other encrypted protocols. One thing I will say is that the presentations that the AdGod folks have done, they've said that they're finding it performing just as well as other encrypted protocols. They support the full range. And in fact, they argue that they think it's coping better in mobile environments, which they have a large user base in. And that's for all the reasons that you would expect with Quick because of the characteristics of the protocol. Next slide, please. So to move on to the question of what we would need to do to support recursive to authoritative, we think that in terms of discovery, Doc and Dot are analogous in the sense that they're both going to have dedicated ports and they both use the same authentication model. So there's not a lot of difference there. Next slide, please. The picture gets more interesting when you look at what the current mapping is and then you think about trying to support XFR. The current mapping that's proposed is incredibly simple. It's very clean, and all it does is map a single DNS query response pair to a single quick stream. So each end immediately closes the stream after sending a single message, and that means the content of the stream is UDP-like. Minor difference is that in Quick, the query ID is 0 because we can use a stream ID to identify the message instead. But we have no 2-byte length field in the current mapping. But of course, XFRs can have multiple responses, so this would need to be modified to support XFR. Next slide, please. So the O2 version of the draft has an appendix where we have an initial proposal for one way we could update the mapping to support it. And there are 2 changes that are proposed for this solution. One is to prepend all the DNS messages with a 2-byte field length. And second is that we relax the mapping so that we allow multiple responses on a single stream so that XFR can work. So in practice, this means making the stream content in Doc more like a TCP connection. Now, the pros are obviously this will allow us to support XFR, and also because Doc has an ALPN and all existing experimental implementations should be using that ALPN augmented with a draft version, we can cope with a change in the mapping. The cons are that it complicates the mapping from that very simple clean one. There's a small overhead introduced, and we have a few new error conditions that we need to handle, particularly at the client end. But otherwise, it's a relatively straightforward revision if we go down this road. Next slide, please. Now, of course, this isn't the only way to do it. There are some other possibilities ranging in complexity. And if the working group decides it does want XFR support, obviously we can enumerate them and evaluate each and decide where we want to go. So this is something that we're going to need input on the work from the working group. Next slide, please. So at this point, I think there are three main questions to put to the working group. One is that we now have implementation and operational progress with this specification, at least in the stub to recursive space. So are there any reservations about moving forward with the specification? Do people still think more performance data is needed, or shall we move forward with the specification in the hope that that enables more experimentation? The second is probably a bigger question about the exact scope of this. Should we do stub to recursive to authoritative, or both? And if we do both, should we handle XFR support? So that's where we are at the moment. So I would appeal for people to have a look at the draft and review it, and hopefully I can get some input from the group today as well on current thinking. That's everything. If we could open up to questions, that'd be great.
Thanks, Sarah. Jan?
Hello, Sarah. Thank you. I read the document. It looks really nice, and I would like to comment on the XFR piece or XFR piece in particular. Mm-hmm. I think it would be really nice if this draft covered like everything that we need to encode in the protocol now. I don't know if we should like cover especially the use cases between different types of servers, like stub to recursive, recursive to authoritative. But I think it would be nice if the protocol itself could encode anything we need now. And I think XFR is one of the things that we need. You mentioned that the problem is with the multiple messages that the server might return for transfers. I'm actually wondering if this is a problem, or I'm actually wondering whether if the server used DNS over quick for transfer, whether it actually needs to send the multiple answers. Because the limitations come from TCP, because we said that on TCP we need some framing, so we added this 2-byte prefix, so we are limited to a message that has this 65K. But for quick we have a different signaling. We can use the stream fin, so we can essentially send much larger response for XFR. So maybe we could make it work with like this simple approach where we have one stream that is used for a single query and single response. On the other hand, I've been thinking about use cases like proxies, because if we change this, then the proxies wouldn't work. We would have to, So I'm just asking whether you have considered this alternative, or because I don't like the 65K limit, and the question is whether we should keep it here in Quick as well.
So it's a really good point. So in the very early versions of the draft, we hadn't included that limit, but it was pointed out to us that the same thing happened with DOE, which was that in principle it could have supported much larger packet sizes, but that again was limited to the 65K limit for exactly the reason you mentioned, which is proxying and compatibility with other transports. So we updated, I think it was the 01 version, included a limit on packet size. I mean, of course we can revisit this, but in some senses, I think we'd be rehashing the argument that happened in DOE, and I expect we would come back to the same conclusion, that it solves a lot of problems to keep that limit.
Okay, thank you. Yeah, in that case, I just suggest using this proposed 2-byte prefix, and I suggest to do it now so that we don't later have to handle the incompatibilities with old clients. Thank you. Good work.
Yeah, and I agree. Sorry, I didn't mention it in the talk, but proxying, compatibility with other protocols is another good reason why the current proposal we have would be quite a natural solution.
Thanks, Jan. Ben Schwartz.
Hi, Ben Schwartz. I wanted to put in a vote for port 853 UDP. We had the DNS over DTLS draft is experimental. It is minimally deployed, and Quick and DTLS are, as I understand it, fully demuxable. Quick was designed to be able to share a port with DTLS. So I think that we should aim to have the final port number when we have a standardized protocol be 853.
So that was a conversation that was had off list, and others can probably speak to the details of the port allocation process better than I can. But part of the concern was that that would make it a longer process if we had to go through that set of arguments, as opposed to just requesting a dedicated port for Quick, and that ultimately it didn't make a huge amount of deployment difference, that if port 853 was blocked, port 8853 might well be blocked. But I mean, it's something we've considered. So yeah, I would be interested to hear what other people think about that as a proposal.
So Sarah, I think that's probably a good discussion point for the mailing list, because my guess is that we're going to get all sorts of different views and opinions on that. So
yep.
we'll
yep.
make a note to discuss that on the mailing list.
Thank you.
Jim Reed.
Thanks. Sarah, I'm a little bit uncomfortable with this idea about the idea of prepending a byte count in the packets. That smells a little bit too much for a layering violation to me. And I'm wondering, maybe the best thing to do here is to advance the document more quickly, is just to sort of draw a ring around the XFR stuff and say, this is still to be worked on and we'll deal with that later. And just get on with the core job of getting out a basic protocol spec which deals with the most common query response type stuff, and just simply park the XFR stuff for further discussion later.
Okay, thanks, Jim. I mean, it does mean that if you do have proxies translating from other protocols, you do have to then have a special case for XFR, which just, if we are talking about applying this to recursive to authoritative, feels like a bit of a wart. Yeah, I appreciate the idea that simpler is better. But then if we had to modify the protocol later to be able to handle something different, we'd probably have to define it as a different protocol with a different ALPN. So that was why we wanted to fully assess if we could support it within the current one. And in fact, it's just a sense of that the 2-byte length is just framing the answers within the stream content, which is an unordered byte stream. So it's really just providing additional compatibility with the existing protocol. But yeah, these are the discussions that we need to have about which direction to take. So thank you for that.
Okay, thanks, Sarah.
Watson.
Some lad from Cloudflare. So my one question, I read the draft and I couldn't really figure out why this is preferable, or what its advantages and disadvantages are to doing DNS over HTTP 3. It might be useful to have a short section in the draft explaining that.
Right, yes. So I think there was a little bit of discussion about this in the presentation at the last IETF. And the argument is that particularly for, or one of the arguments is, particularly for recursive to authoritative, you're then packaging the whole HTTP layer around your DNS queries. When I think what we heard at that meeting is that most recursive and authoritative implementers see that as an unnecessary overhead on that path in particular, and would much rather have the cleaner, lighter, pure quick mapping that's proposed in this draft. But again, if other people have other recollections for that, please speak up.
All right, David.
Hi, good morning. Happy to take it to the list, but I wanted to make a very short point about the port number. What I we did sorry, I used to be the tech lead for Quick and Chrome. When we did some experiments there a while back, not all UDP ports are created equal in getting over the internet. So I might suggest like actually just going and using 443. Quick demultiplexes by LPN, so that would allow you, even if you wanted to share both services on the same port, it would just work. I totally get your point about fighting an uphill battle with purists, but this might be the best deployment strategy. Just food for thought.
Okay, that's an interesting point. Thank you. Yeah, we'll take that board.
All right, any other questions for Sarah on DNS over quick? All right, so I think we have a couple of discussion points for the mailing list to try and iron out the details of what we want in the draft. So we'll make sure that we get some discussions started on the mailing list once the meeting is over. Thanks, Sarah.
Thank you very much, everyone.
All right, next on the agenda is Oblivious. Are you presenting, Chris?
Yeah. Awesome, thank you. All right, good morning, everyone. Here to talk about Oblivious DNS over HTTPS. This is something we talked about in this group, I think, back in Singapore, and there's been a lot of work both on the specification side and the implementation and deployment side, and so we wanted to bring an update to the group, remind folks what this was, and talk about next steps. Next slide, please. So at a very high level, the pitch is quite simply that Oblivious DO, or DNS over HTTPS, is a protocol to proxy DO queries between a client and a resolver, such that the resolver, in this particular case, only sees the queries, and the proxy only sees the client and the target, and is not able to link the two together. Next slide, please. To actually use the protocol, the client requires sort of very minimal information. The first of which is the name and public key of a target resolver, in like quad 1, for example. The second is the address of a proxy that's willing to actually support the protocol. The sort of minimal privacy assumption that we're making here is that the proxies and targets do not collude. And noting right now that there's no technical mechanism for enforcing that other than like checking certs and seeing that they're not, the same entity or organization. But that's just sort of par for the course here. And as I was stating earlier, the privacy goal is quite simply just to ensure that only one party in this whole entire system, that is the client stub resolver, has access to both the contents of a query and response, or the plaintext DNS messages, in the IP address, and no other party, be it the target or the proxy, is able to link these two together. Next slide, please. So the protocol works roughly as follows. There are more or less three or more entities in the system. There is a stub resolver, there is a proxy, there is a target, and then upstream there's the rest of the DNS, or we're just referring to this as a sort of resolver. And most often, at least based on performance considerations and performance results or experiments that we've done, it's best if the target and resolver are sort of co-located, one like right next to each other, or the target is itself a recursive resolver. But we've split them out here just to illustrate that how ODO is sort of built on top of DO. Next slide, please. So the very first step is the client stub somehow discovering the target public key. There is a mechanism in the draft to actually put the key in an HTTP service record right now, but this is not mandatory, and I'll touch on this a little bit later. There are other discovery mechanisms possible. In fact, we've implemented another one in production as well. Next slide, please. stub and then proxy then establish sort of persistent HTTPS connections between each other. So the stub would connect to the proxy, and then proxy would, in theory, have a persistent connection to the target. Next slide, please. And then through that persistent HTTPS connection, it sends a public key encrypted query from the stub to the target, such that the target can decrypt it using its private key, recover a query, and then send it upstream to its resolver to be answered. Next slide, please. And then the response flows back naturally from the resolver to the target, where it's encapsulated again with another layer of sort of application layer encryption and sent over these HTTPS connections through the proxy back to the stub. Next slide, please. So there's obviously a number of different ways we could go about building this sort of system that achieves this unlinkability goal. The first of which is, just simply using connection-oriented proxies like Connect or SOCKS. The trade-off here, or the difference here, is that Odo was specifically designed such that every single query is unlinkable. So a target, upon receiving 2 consecutive queries, can't tell that they came from the same client. Unless, the proxy could do something very silly, and that is to say, open up a fresh HTTPS connection for each query. But again, for performance and deployment reasons, we assume that to not be the case, that proxies would do sane, sensible things. So if you were to use a connection-oriented proxy and do end-to-end HTTPS between the stub and the target in this case, you would either have to pay that connection setup time for each query if you wanted unlinkability, or you'd have to permit some sort of bounded linkability, which is sort of the approach that Tor, I guess, DNS over Tor uses, in that circuits are established for a short amount of time. You can send queries over them for a short amount of time, and then the circuit's turned down and a new one is spin up, and get you the same properties, but again, you're trading off linkability for performance reasons. And Tor would, of course, work here as well. It's kind of in the same bucket as Connect and SOCKS proxies. In fact, there was a presentation at NDSS this year at the DNS Privacy Workshop describing someone's experience running DNS over Tor for a long time, over the course of several months, I believe. Basically, the conclusion was it's not that bad. However, Tor is sort of a very heavyweight solution for this particular I guess problem we have here. In particular, it requires multiple hops. It does a bunch of things to mitigate traffic analysis on top of just regular proxying and encrypting. For that particular reason, it's not sure. We're not sure that it's the best fit here. Also, Tor is not sort of widely deployed in most user agents and most servers. There's also Oblivious Http. In fact, Martin Thompson will be speaking about this at Sec Dispatch later in the week, so I'd encourage you to check that out. It should be not surprising that there is a strong overlap between Oblivious Http and Odo, and in fact, that's very intentional. Oblivious Http is sort of the successor to Odo, sort of V2 to the V1, but Odo is, in its current state, something that is we consider to be fairly well refined, analyzed, and shipping. And so while certain aspects of generalizing a generalized OHTTP protocol are sorted out, in particular, concerns around this proxy supporting OHTTP and becoming sort of an open proxy, we think Odo is a perfectly good candidate for a V1 in which we can experiment with, use to sort of build this system, assess its capabilities and its performance, and then when ready, shift over to something like OHTTP when the protocol is more stable. Next slide, please. So there are obviously a number of deployment questions that will likely come to mind if you've read this draft, or if you've or if you've been thinking about this for a while. First of which is undoubtedly key discovery, as I was alluding to earlier. And I think this will vary most likely by deployment scenario. So the draft, as I said, has a current mechanism for packaging up all the configuration and public key information that a stub resolver might use, and it specifies a way to shove that in the DNS, because that's our, I guess that's the answer to most things these days. But we also, in our production endpoint, we also package up and advertise this information in a well-known HTTP endpoint. And given sort of that's likely the direction that OHTTP will go as well, very well might be that's sort of what becomes the de facto mechanism here. All that is to say that key discovery in particular is definitely out of scope, similar to how like discovery of DOE resolvers is out of scope for DOE. What we're describing in the draft is just sort of the packaging information for this configuration material. The second important question that might be on your mind is who will actually proxy. So in our deployment, we partnered with Equinix to offer up proxy services specifically for ODO for user agents that are interested in, and we expect this to sort of be the pattern or the deployment pattern for protocols of this type, where we have good Samaritans or just entities acting on the behalf of clients, proxying for well-known targets that support the protocol, or proxying to targets that they can verify support the protocol. And the last of which is this notion of non-collusion. As I said, there's no technical mechanism in place to ensure that this doesn't happen. In fact, that's very much sort of out of scope. The point of ODO is to sort of put technical barriers in place such that people can enforce whatever sort of policy they want in terms of which proxy they're going to talk to and which target they're going to speak to through that proxy, and to make it sort of difficult for entities to do this linkability that I was alluding to earlier. But of course, this non-collusion is sort of necessary and of course required for the privacy guarantees that we're talking about here. Next slide, please. So just to give you an update on the status, this is used in production. We have target support at Cloudflare's Edge right now. There are a number of different client libraries and proxy implementations available. These are, people are dogfooding this right now. It is, the proxy is running and we're actively using it. We're trying to, we're standing up this infrastructure first and foremost to sort of do these performance tests to see, what is the actual user experience impact in terms of this sort of proxying protocol. We have some preliminary data that was published at NDSS this year, or discussed at NDSS this year, that shows, without getting into the details, that page load time and response latency are not, quote, I should have quotes around significantly, but significantly impacted. And I say quotes because there's a lot of variables in terms of where the proxy exists on the path between the client and the target, whether or not connections are reused appropriately and connections are pooled. So there's a lot of room for improvement on the results that are there, and so we're committed to continuing our experiments with stub resolvers to get more data, to do more performance analysis, to make sure that this is something that's sort of livable on. I'd also like to state that thanks to Jonathan Hoyland, we have backing format analysis in Tamron to just give us confidence that this is something safe to do right now, as it's currently spec'd. Next slide, please. So the question for the group is, given that there is a sort of a interest in this, well, I'm obviously a little bit biased here. There appears to be interest in this particular protocol. People are investing in it. It's shipping. The question for the group is there interest in adopting this as an experimental V1, as something that we can deploy, live on, and get confidence in before we move to some future V2. be it based on OHTTP or whatever. And with that, I will pause for questions. Just noting, you may hear some like snoring in the background. It's a small, tiny dog.
Go ahead, Paul.
So thank you, Chris. Actually, especially for that last comment, I was going to actually ask on the chat, is anyone else hearing that? So congratulations for your dog. It's 4 in the morning. So I think this is a reasonable experiment, but I don't think it's worth having the working group working on it, because as you said, you've already got, it deployed. We know that there's a V2 that might be more generalized and such like that. I think this would be perfectly reasonable to take straight to the independent submissions editor, as in, we thought about it, there was some discussion, it's clearly not crazy, we've actually got some proof that it's a reasonable security concept. The other reason why I think I would be hesitant to take it to this working group is I still, and Chris, you've heard me ask this many times, I don't know how many users will actually understand the advantage, I don't know how many users there are who say, I don't trust my immediate upstream to not collude with the upstream beyond them, particularly when the best performance is when the two of them are the same organization. I think that'll get answered better from the general HTTP BIS working group work. And so I would say don't bring it up in the working group, but get it published so that people can take a look at it and bang on it. Thanks.
I agree that explaining to users what are the privacy benefits here is tricky. And I hope that we don't have to go into sort of technical details here, because even as experts, I guess and sometimes it's hard to reason about. So yeah, thanks. Eric?
Yeah, just comment on that last point about explaining to users. I don't expect this to be something that can be easily explained to users either, but we can get good benefit out of this if the browsers implement. We can do things without the users having to understand anything at all, similar to how we do auto upgrade today. So I like this proposal. Just my one concern is, similar to a lot of people in the chat, just the upcoming alternatives and such. It seems like if this is just a temporary thing before new stuff like Oblivious HTTPS is very likely to take over, then this doesn't seem like something that should be a full-fledged adopted standard track RFC.
Yes, definitely not standard track.
Say, yeah, let's do this right now. But it's the alternatives. It's giving me scared of maybe this isn't time to do anything other than just an experimental and just try to get some stuff in the meantime while this works for now.
Yeah, sorry, I didn't mean to cut you off. There's a lag. Yes, totally agreed. We are not interested in making this proposed standard, given that there's something slated to be better OHTTP in the future, but there is a use case for this right now. We are actively shipping this right now, and we want to actively experiment with it. So experimental is great from my perspective. So I'd be happy with that.
Okay, yeah, sounds good.
Thanks, Eric. Tommy?
All right. Hello, can you hear me?
Good.
Hello, can you hear me? Checking.
Yes, we can.
All right, sounds good. Yeah, so just to kind of echo what's been said, I think experimental is the completely appropriate thing for this. If the working group doesn't want it, I think then it would make most sense for it to just kind of go directly to independent submission or AV sponsor or something to be experimental like that. However, I would, as an author, express that I would prefer to see it adopted as a fairly quick processing thing for this working group, just to have the opportunity for the working group to have the reviews, to give input on some of the text, particularly around any language that we can improve for DNS considerations into the architecture. Since if we view this as a step towards something that's going to be generalized with Oblivious HTTP and used for DNS in the future, having the thought and consideration of the group on how kind of best to think about this area, I think would improve the document. So if people would like to do it, that'd be great. I'll also speak as an implementer that we are planning on having support for this at some point from the Apple side, and that would be able to reach a lot of users. And it can be done in ways that don't require them to have a deep understanding of the trade-offs here, but still provide a benefit to them in their privacy overall. So yeah, I think it could go either way. Experimental is definitely the right thing. And I would ask the chairs maybe if we could get some type of poll on just interest on the best way to go forward with this.
Thanks, Tommy.
Yeah, so just a quick response to that, Tommy. I mean, we can either do a poll now, or we can just repeat the poll again on the mailing list so that everyone can participate. So, my suggestion, unless people really want to do a poll right now, is we'll make an action item to poll the working group on adoption, and we'll elaborate on the three primary options, assuming that experimental is what everybody agrees to. Then it's either the working group adopts it, independent stream, or AD sponsored. Yep. And the third one will require us to have a chat with our area director to see if that's something that he's interested or willing to see.
So Brian, we could use the show of hands tool. That seems to, even Eric Nygren said that works pretty well. I can fire one up here real quick if you want. Oh,
go ahead. Let's play with the toys.
While you do that, I just want to reply to a comment in the chat, which was that discovery is going to take a long time to sort out. And I definitely agree, which is why it is distinctly out of scope for this particular document. We are not trying to solve the discovery problem here. That is something that specific deployments of this problem can solve, future specifications can solve. But it's definitely not for this.
Yep, thanks. And I always have the opinion we could adopt something and then decide never to do anything with it. We can noodle on it for a bit and realize it's not, but some people feel that's burning a lot of working group time. So I think the opposite, right? I think sometimes you get folks really thinking about stuff like this. You come up with a bunch of different, possibilities. So.
All right, so while we're rolling the poll,
we got Watson going.
Yeah, let's get Watson's comment.
Watson from Cloudflare. I'm scribing Ecker's comment. I am stuck in RFC EdDep for now, but I'll just say what I think about Odo versus OHTTP, which is that I like what's on the slide, but hopefully I'd like to see a merge. I suggest we have Odo as experimental in case there is no merge, as we expect Odo to eventually be replaced. There's a bunch of +1s in the chat to experimental.
Thanks, Watson. Ben?
Thanks, Watson.
Hi, Ben Schwartz. I said earlier that I supported adoption, but I've just heard a sort of change in the context of the discussion with the authors, noting that there's substantial deployment already. I think that actually suggests that maybe this isn't really a great fit for adoption, because I think adoption by the working group really means change control passes to the working group, and we would need to think. I think it would be right and reasonable for the working group to take a step back and try to figure out what is really the right long-term solution here. What is the integration here with multiple protocol discovery? How does this work in a world where there's DNS over QUIC in play? How does this fit into the broader DNS architecture? So, I think I would be most interested in the working group taking this on, as a sort of to design a version 2 and let this version go out basically as is from the authors.
So I definitely agree that those are things we need to sort through, and that's specifically why I think adoption as experimental in this working group is perhaps the right move here, so that we can work through those issues. I don't know that means, I don't think it means that we need to be like focusing on V2. The point of this exercise, as I see it, is to make sure that we sort of work out all the kinks for this initial V1 for this experiment, such that when V2 is ready, we will have a much easier time getting that out the door. But
sure,
I mean,
it sounds to me like you're, like basically it's too late for compatibility breaking changes in the specification. And that suggests to me that this should probably just go get an RFC number and it should just move ahead, and we shouldn't try to mess with it here, basically.
So to be clear, we are totally open to handing over change control for this particular document. Should that be what's in the best interest of the document? We're not like just seeking an RFC number right here. We're trying to figure out what is the right way to shape this protocol such that it is deployable and people can live on it. And so I'm not sure I see an issue in that particular respect, but there's more people in the queue, and maybe Tommy or David want to specifically speak to that point.
So actually, Chris, I want to jump in from the chair perspective, and I think there's a little subtlety in what Ben is saying there. The question is given the amount of deployment that you have, do you want a document that reflects the current deployment, or do you want a document that is going to be potentially changed that doesn't reflect the current deployment?
We expect the document to change, and that's the whole purpose of this. We are by no means, rigid with respect to what's currently in the doc, be it on the protocol details, crypto details, what have you. Yeah, I hope that is clear.
Okay. Ted?
Thanks. The point I got in queue to make a while back was actually on the caching semantics and what the experiment is going to tell you. It sounds like there's a great deal of interest from the proponents of the document to use this experiment to work out what the relationship is of this work to the rest of kind of the way the DNS works. And I think that's very valuable, and I support an experimental on that behalf. I want to be a little bit cautious, though, in drawing any conclusions about what that experiment means for a broader use of Oblivious HTTP, in particular because the way caches work is sometimes subtly and sometimes not so subtly different between the way DNS caches work and HTTP caches work. And I think one of the concerns I would have is us presuming that success in a protocol designed for the more limited set of MIME types and the DNS caching mechanism was necessarily a harbinger of a good result in the HTTP side. So I definitely support this going forward, and I do want us to be a little bit cautious, though, in thinking about what the results of the experiment would mean, because I think there is a strong chance that you will end up with an Oblivious DO that is divergent from Oblivious HTTP because of the different caching semantics, and in particular, some of the risks involving the relationships among different caches in the two different arenas. Thanks.
Thanks, Ed. That's a great point. There are subtle differences between this and OHTTP, such that we couldn't just lift the results that we get from ODO to OHTTP and call it a win. We certainly have to be careful and mindful in terms of how we do the migration. But our hope is that we can use ODO and track it alongside OHTTP as close as we can, such that the divergence and delta between these two protocols is very minimal, and is not, the delta is not due to any like a security or crypto or whatever changes. It's more about like the differences between the sort of underlying technologies like DNS versus HTTP. Tommy?
All right. Yeah, so first, yeah, thanks, Ted, for that point. I think that's very true. And I think that difference of scope is precisely why I think it's interesting to pursue the Odo experiment on its own now, because that scope is, I think, more tractable in the short term. To the overall point of change control that was being brought up earlier by Ben and Paul, I do want to make it very, very clear that, you know, if it's adopted, DPRIVE as the working group would, of course, have complete change control over the document, over the protocol. The document is already designed to be versioned. When we've been doing deployments already, it essentially has a draft aligned version number. This is very much taken from the experience in Quick. So I think, you know, that's a model in which you saw that, you know, Quick has seen, you know, a lot of deployment prior to it being an RFC. And while I do strongly want to express that, you know, we will be using this as an experiment and doing a deployment, it's also one that's versioned, and we would try to keep it up to date and in line with whatever the working group wants if the working group was working on this. So I don't think that should be anything that blocks us. And yeah, the authors would be very happy to have the beneficial input of the group on improving the document.
Yeah, thanks. David?
Thanks. Sorry, waiting for the microphone to kick in. So yeah, David Skenazy. In this case, my relationship to this is my job for the last 2 years has been making Google Quick be IETF Quick. And if we had said when we started that effort, oh, no, we can't bring this to the IETF because it's already deployed, we wouldn't have Quick. And I think Quick is a great thing for the internet, and the IETF has brought great things to Quick. So not to belabor the point and repeat what Tommy has said, we should do the exact same thing here. The fact that this is deployed is a huge argument in favor of making this happen at the IETF, not against. We discussed running code at this SDO, and so I'm fully supportive of moving this forward, even if we want to make it just experimental at first or what have you. But the fact that there are deployments is an argument to do this work, not to push back on.
Thanks, David. Eric?
Yeah, just a point I just thought of in favor of why we want to have Oblivious DO be a thing, even if OHTTP is potentially coming up soon. It's entirely, not necessarily likely, but entirely plausible to me that we could easily find the proxy ecosystem developed for DNS, but not necessarily for the general solution. It seems to me that DNS is a specific case where the web is used to having Good Samaritan servers show up and be there without any necessarily direct income potential. And we could easily find an ecosystem where everyone who wants to run a public Odo resolver also runs a proxy to point to any other public Odo resolvers, versus we could easily find ourselves 5 years down the line that no one wants to run OHTTP or proxies at scale, but we have Odo proxies at scale, and we'll be very happy we have Odo as a possibility while we still are trying to figure out how to make the ecosystem exist for OHTTP.
Yeah, good points, Eric. Thank you.
All right, thanks, Chris. So just as a note, the poll showed 25 people interested in adoption and 13 not interested in adoption. We'll ask the same question on the mailing list so that we can get more participation from other people who may not be able to be in today's session. So we'll make that as an action item for the chairs to solicit input from the working group. All right, moving on, we have Peter talking about the opportunistic ADOT work.
Yes, hello. Can you bring up the slides?
I am in the process.
I see that.
All yours, Peter.
All right, can you hear me well?
Yes, we can.
All right, so my name is Peter van Dijk. I've been working with Paul Hoffman on a draft to basically solve the working group charter's problems, or at least part of them. Next slide, please. Just a reminder, this is an adopted draft, although a lot of changes have happened. But if you want other changes, we will make them. Next slide. The terminology slide is just for people reading this later, so we can skip that. Next slide. Yeah, thank you. So the basic principle of this draft that has been unchanged over various revisions is the unauthenticated case. If we assume a resolver with an empty cache, it gets a query for, say, www.example.com. It goes to the root, it goes to .com. Eventually, it will learn the name servers for example.com. This resolver, having no knowledge of the availability of DOT or any other encrypted transport for these alternatives, will ask this question over plain, classic DNS over port 53. The resolver gets the answer from the name servers. It sends the answer to the client, and the client is now no longer waiting. So any magic happens outside of the brief instant where the client is waiting for an answer. Now that the resolver is done responding to the client, it goes out and learns whether these name servers support DOT. The mechanism by which it learns this I will cover later. The resolver then remembers that NS1 and NS2.example.com support DOT. Then at some point another client might come along, ask for mail.example.com, and the resolver, now still remembering that DOT is available, will do this query over the encrypted transport. Next slide. So a brief history of this draft. The first version published by Paul tried to do full opportunistic as described in 7435. It also had the mechanism where the discovery happened after a client was handled. The discovery mechanism in that version of the draft was probing the DOT port, being 853 or perhaps another port if we decide that recursive to out DOT will use a different port than stub to recursive. We then found out that the working group also had interest in a fully authenticated protocol for encrypted transport from recursive to out. So in the second version, we added a skeleton of fully authenticated operation. This was definitely not fully worked out, but the point of this was to allow unauthenticated, opportunistic, or whatever you would call it, to be compatible, interoperable with some fully authenticated defined protocol. We switched to TLSA here because this avoids adding another cache to the resolvers, which the first version called a transport cache. And the beauty of using some DNS record for the discovery is that DNS resolvers generally already have a record cache. Then shortly after we published this, the draft from Ecker and other authors appeared, which uses SVCB as a discovery mechanism, which means these two drafts now overlap in some places, conflict in some places, and I suspect the next version of our draft will be shorter than the second, but we will get to that. Next slide. Just to put everybody on the same page, I'll be going through some comparisons between the two drafts. The first two lines here are about my and Paul's draft, and ADOCS is the draft that Ecker will be presenting after this. So we use TLSA on the NS name for discovery. ADOCS uses SVCB on the NS name, or perhaps in the additional section from the parent if it turns out parents can and will cooperate in that. We feel that we could change to SVCB to be compatible with the authenticated draft. Next slide. TLSA is very suitable for DOT and DOQ. I think Sarah mentioned something similar in her presentation earlier as well. But TLSA is not suitable for DOH. The ADOCS draft that uses SVCB would make all three transports supported, and that is another reason it might make sense for us to also change to SVCB. Next slide. As for authentication, we define two modes in the current draft. For the unauthenticated mode, the TLSA or SVCB is just a signal. There is no authentication. For the authenticated skeleton protocol, we defined the TLSA from service discovery would currently cover that. And for the ADOCS draft, if we read it correctly, and I'm sure Ecker will do a better story on that after this than I can right now, the authentication might be web PKI, TLSA from a second request, TLSA chained in the TLS handshake, etc. Next slide. Here we get to the interesting differences. This title is written very specifically. The resolution if no service is found in the cache. So as I mentioned earlier when describing the protocol, from an empty cache, the unout case would just use classic DNS over 53, then later go figure out if TLS or DOQ, whatever, is available at all. For the authenticated case, of course, you need to do that lookup first while the client is waiting. And the ADOCS draft, which is authenticated, obviously also needs a lookup first. Next slide. Now, assuming that things are in cache, either from a previous attempt or because the lookup has been done before the client even can even get results. In the unauthenticated case, we try every encrypted transport to every server. If all of that fails, again, we go back to DO53. For our authenticated case, if encrypted transport is available, but we cannot make it work, we fail. The ADOCS draft says you should try all, and currently is a bit open on the handling of the full error condition. Next slide, please. Now, if you can connect, but you cannot authenticate, then the unauthenticated case just ignores the failure and might get encrypted transport that has not been verified, but is still safe to passive attackers, etc. The authenticated case in the ADOCS case, of course, fail the connection then. And here it is clear that the first two items being in our draft and it's the third item being in the ADOCS draft is a weird split. So maybe our authenticated case should go away or move into the ADOCS draft. Next slide, please. So to recap, our document started as opportunistic. Then we added at least some room for combining or being synchronized with an authenticated case when there was no other document doing that. Now that the ADOCS draft is under active consideration, we think it would make sense if we remove all authentication from this document while keeping the discovery mechanism in. Although we probably switch from TLSA to SVCB for that. And depending on how things play out in publication, it might make sense to move discovery into a third document that would then come before both the unauthenticated and the authenticated document. That is all I have, and I agreed with the chairs that Ecker would present now first, and we can do all questions after that. Thank you.
Thanks, Peter.
Okay, you're sliding the slides. Great. There we go. Perfect. So I'll just yell next slides when we're ready. So thanks for that overview, Peter. As you said, this draft came in a little late. Hilariously, the draft is actually called Draft First Correlate DPRIVE-20210309-1200 the latest, because when the Secretariat hoisted it out of the GitHub repository, they didn't substitute latest with 00, but there we are. In some future version, it will not have latest on the end. But thank you for the Secretary for doing it. Thanks for Eric for approving that. There's obviously been a bunch of discussion about how you would do this, and so we tried to take a crack at it using Service B. Next slide. Okay, so I actually want to take a step back from the question of mechanism and talk about threat model first, because I think it's helpful to think about. A lot of this discussion has gone back and forth, but I think has left us in kind of a confusing situation about what can and cannot be done. So I want to talk first about like what we're trying to accomplish, and then what the constraints that I see are, and those kind of apply, I think, regardless of whether exactly what how you spell the indications. So there are three threat models we talked about. I think one is the classic 3552 threat model, where the attacker controls is on path and an active attacker on path between the recursive and all the authoritatives. This is like often the crypto calls a Dole-Eviao attacker. Then we have a passive attacker on path between the recursive and all authoritatives. And then we have some edge case where the passive attacker is on path between the recursive and some authoritatives. So that's probably worth considering, but I'm not considering it here. So I'm assuming that the attacker at minimum can see all the traffic coming out of the recursive and maybe can tamper with it. And that becomes relevant shortly when we think about what works or what doesn't work. Also, before I move to the next slide, I want to point out that we're in a bit of a funny state here where and we'll see this when we get to DNSSEC, where where TLS is providing, although DNSSEC is the ultimate backstop for integrity, integrity and data origin authentication are intertwined with confidentiality in sort of an annoying way that will make our lives harder. Next slide. So I think the first question we have to ask is what needs to be encrypted, and I think this is obvious, but I want to just hammer it home. Generally, you need to encrypt the traffic of both the parent and the child, and the reason for that is that the sort of common case is effectively that you're resolving like example.com, right? And so if I go to .com and I ask for example.com, well, that query reveals I'm asking for example.com. And then when I go to ns.server.example, even if it's not run by example.com, so it's run by somebody else, that also reveals the query example.com. And so both of these need to be encrypted, or you don't get any real value. There's some edge cases where that's not true. Where you're asking for x.example.com, where x is not just where X is part of some large anonymity set. It's not like www, but basically, when example.com only has only has two children under it, male and www, or worse yet, it's just example.com. You're not getting very much value out of only encrypting the second query to the real authoritative if you don't also encrypt the query to the parent. So I think that's a really important insight to have, because it means that some of the things you might naturally think you want to try will not work properly, or will not get you the value you're trying to get. I hear people. I did see there was asking for questions at the end, but if anybody has strong disagreement with something I'm saying, I think it's actively wrong as opposed to just dumb, please do pipe up, because it's important to get these things clear. And everything I'm going to say proceeds from this basic analysis. Next slide. So the basic idea here, as Peter suggested, is to use Service B. FTP is also something we've been working generally. So the key idea is the authoritative has an SVCB record, and the SVCB record indicates two things. One, it supports encryption, and two, what protocols you'd like to support. It actually may serve three things. It may also serve which form of authentications you expect to authenticate with, but we can deal with that in a minute. I probably should highlight this point. I think for operational reasons, generally you're going to want it served by the parent and additional data, but we can get to exactly when that's needed and when it's not in a minute. But that's definitely part of the concept here. So once you have SVCB in hand, you connect to the indicated server with whatever the indicated protocol is, and you authenticate as I put it here, in the usual fashion. Namely, this does not take a position on how you authenticate, though again, I'll get to that later. If you can't, once you've gone through like all the different options of like all the different name servers, all the different protocols you support, then you hard fail when you can't negotiate. If none of those work, you hard fail. There is, I think, one special case, which I'll get to in a minute, where you might fall back. Roughly, that case is that none of the authentication mechanisms that the server claims to support, you support. Next slide. So here's like the same diagram, except like with, me not bothering to color things in, that they're TLS, and indicating this glue record being sent. So like this glue record is like a real point of contention. So I'm going to get to, I'll get that in a second, but I think there's like important reasons why you probably need it. Next slide. Okay, so right. So what if you can't? So other people suggested that you can't use the glue in the digital data. Basically, so the fallback in case you don't have glue is the recursive can connect the nominal authoritative, namely what it received an NS record, and ask for SVCB. Given that you have no in sort of naive case, you have no indication that the nominal authoritative has supports TLS, and so you're going to do it over 253. At best, you're going to do it opportunistically, because again, we have this chicken and egg problem where I only have the NS record, and I don't know the server that I'm going to support connected with TLS actually supports TLS. So like this only like really works properly in two cases. Or in one case that has two requirements, one of which I didn't lay out. First, it only works if the authoritative zone is DNSX signed, because otherwise, then whatever information you receive about like whether it supports SVCB is just like lies basically, and you have an active attacker on the pipeline. It also only works like really well if there's if it's a zone which doesn't not responsible for thinking itself, because otherwise otherwise you're asking for the, so if example.com is served by ns.example.com, then when you connect to it and ask for example.com, you're just kind of like a hole because you've already asked for it and you didn't use TLS, so it's kind of like game over. So again, I think this additional data glue is actually pretty important if we want to get wide deployment, given that we don't have anything like universal DNS deployment. Yes, Paul. Oh, now what? I can't make you live. Paul? Okay, I guess I'm going to move on, and when Paul figures out how to be audible, or Ben.
Hi. So I think there's even another reason that makes this insecure, which is that the NS, the name that you are connecting to, even if it is DNSX signed and has a service B record, could be the attacker because you didn't get it over an authoritative channel, even if the parent is signed, because the parent can't sign the glue records.
Right. Exactly right. So the child has signed the glue records, but you've already asked for the child.
Right. Even if it's out of bailiwick, there's just no anyway. So I think there's one more reason why this doesn't work.
Okay, so Paul, if you ever figure out how to get audible, I'll shut up. I'll let you talk. Okay, next slide, please. Oh, sorry. Can you back for a second? Back one slide. I will note there's one special case, which is Paul, I think, observed an email that people aren't going to want to serve SVC in glue. However, currently the root zone actually forbids you serving SVCB at all. But like there's a temporary fix where you like basically pre-configure the recursives or the TLS status for all the TLD authoritatives, which like aren't like an enormous number. It's not amazing, but it's like possible. You certainly wouldn't want it for the next level ones. Next slide. So like, I want to hit on this, like I think Ben was just saying this, like, aren't you trusting the parent? And the answer is absolutely trusting the parent. And this is the part where like TLS is actually writing integrity and data authentication, and not just and not just confidentiality. And the reason is, as Ben just said, you need that to get the NS record for the child. Otherwise, you have to worry about the attacker lying to you. So I'll finish talking in the slide, Paul, and then get out of your way. So DNSSEC does help here in the sense that that even though the NS records the parents that are unsigned, by the time when you connect to the child, you can tell that you were just lied to. But at that point, you've already connected to the server and found if the NS records are bad, but you've already sent stuff over. So and of course, you've also already revealed what you're trying to do to the parents. If the parent's lying, you're kind of in real trouble. So basically, the bottom line is you need to trust the parent and the child together, or the thing is just game over. Paul.
Okay, so can you hear me now?
Yes. Yeah.
Okay, great. Sorry. So it's not about people not wanting to serve SVCB records at the parent, right? It's just the infrastructure we have currently has absolutely no support of sending those via EPP and other mechanisms from the child to the parent. And it's really hard to get new records into this system. We're still trying with things like CDS and CDNS key to work around that system to get records there. So there's absolutely no way SVCD will ever have a realistic chance of being there at the parent. It's not my thing. It's not like some people don't like it. It's just the reality of the operation of DNS and registry system. So that's one thing. So then I totally agree. You can do SVCB at the child, and for those name servers that are in bailiwick, you just have no chance of keeping your privacy, and a lot of the privacy is based on the fact that your name server that you're resolving initially doesn't leak enough data, and then subsequent domains, the thousands or millions of domain hosted on that name server, you can prevent from leaking if you trust the connection you have to the parent.
Thank you. So I have no particular brief for SVCB versus anything else. I think my fundamental thesis is something. I think the point of this set of arguments is that something has to go in the parent that is not going to work very well. And so if there's some other thing we can shoehorn to the parent, I got no if it's SVCB encoded in the NS record, I got no particular brief for that. But I don't believe this will work successfully unless we can shove something in the parent.
So if you want, I wrote to the list, there's only very few options you have if you want to encode something at the parent, right? You either encode it with the DNS key flags, but then you need DNSSEC, and then it gets encoded in the DS record, or you're going to encode it into the name server name, the DNS curve style from the past. And then you're going to have the question of whether you're going to put a PIN in or not for this, or whether you're going to put the public key in or not, and we can discuss that further on the list, I think.
Sure, I'm perhaps less fatalistic about people's willingness to to solve the technical problems about putting this in the parent, but okay. Jonathan?
Yeah, can y'all hear me? So I think I've seen this in the chat too, but I also I don't like this idea of we can never do anything new in the parent, because that's going to strongly limit us and result in hacks where we're abusing record types for things they were never intended for. If it really is the case that the registry ecosystem today is so so frozen that we can't ever do things like this, then let's say that. Let's go into DNSOP or something and say, okay, we're never adding anything new to the parent. Everything new has to work with the child, because I just don't see a path forward. We all agree the parent is the right place for it, and then we say, but we can never change the parent. So we've got to find a way to get past that. And if that means that there's a number of interim methods until we get what we want in the parent, that's great. That's fine. But to me, this idea that we can never change the parent is just a non-starter for any of this.
Jim.
Yeah, we can consider things like the problems around provisioning at the parent. That's one set of issues. But the idea we stick more information to the parent will complicate the zone cut semantics. And we've already been very badly burned at in the IETF with DNSSEC deployment. So we need to think very, very carefully, not just about the provisioning concerns, but also about the implementation concerns for resolving for people writing resolvers.
Thank you. Okay, I'm going to move on, I think. Someone needs to mute. Okay, so next slide, please. Okay, so I think the second contentious point was how you authenticate the resolver. As you see, I'm somewhat dodging this by saying the usual way. But my basic thesis is we shouldn't take a position on this. You have the NS record in your hand, and hence you have the name, or maybe an IP address. And so you have, so we have conventional choices for how you authenticate people once you have their name and use TLS. We have the web PKI and we have Dane. And obviously for Dane, to avoid the security concerns, you're going to want the TLS extension, but we have a TLS extension, I think, in the ISEQ. I know there's contention about exactly how that should be done, but like it exists. So I think like I'd be kind of sad if we were. I think it's a mistake to try to nail down this too early. I think there's arguments to be made. I've seen the arguments for and against both web PKI and Dane, and I don't want to recapitulate them here, but I think let's let the market sort that out. One important point here is that what happens if I try to connect to you and I'm recursive and I only support web PKI and you're authoritative and you only support Dane, and that looks like a misconnect. There's no way to authenticate that. So we don't know, and so I don't want to hard fail because actually you're totally cool, but I don't want to fall back because otherwise we have an attack problem. So I think we need some way for the authoritative to indicate what kind of credentials it has, and the idea would be that the authoritative would say, look, I support web PKI, and if the recursive only supports Dane, then you don't treat that as a hard fail. And I think Robert Evans suggested that what you do is under those circumstances only, then you fall back to opportunistic, because you might as well do TLS and you just don't validate the cert. But the point being, a secure indicator that you can trust that says you were never going to be able to validate this cert, as opposed to just you discovered accidentally you couldn't validate the cert. Next slide. Right. Sorry, I forgot the slide here. It was here. Right. So if there are no common auth methods, this is just what I said. This is also potentially useful for retrieving the SVCB and NS records from the child. Next. Right. So I mean, and the bottom way to reason about this is TLS all the way down, right? This works if the certificate is good, and you have some strong way to get and you have some reasonable way to understand what the NS records look like, either because you got them from a TLS connection initially, or because they were somehow DNSSEC signed, and again, you have some reasonable way to trust SVC records. And so as long as you basically start with something secure, then you can continue walking down the chains in TLS, whether things are DNSSEC or not. So the question is how you start with things that are secure. And so there really are two main options. One is you have some sort of thing you've retrieved over DO53, three main options. One over DO53, and it has DNSSEC. One of which you retrieved over TLS, and so you're trusting TLS, whether or not there's DNSSEC, and the third is something is manually configured. And I imagine we're going to need some combination of each of these three, but the point is once you get into some secure loop, then you're good to go. And so obviously, at the very top, things are going to be manually configured, whether there's DNSSEC or TLS, but then as you start moving down, once you get into a secure zone, you're secure as you continue downward. Next slide. Right. So I guess next steps. So I think Peter kind of teed this up. We think this is an interesting way to proceed. We'd be interested in seeing the working group take it up in some fashion with document mechanics to be determined, I think, by the chairs. I think it's been floated that there's some interesting ideas from NS2 that we might try to pull in. As I say, I think if you had to ask, my co-authors may want to speak for themselves, but if you had to ask what I think the important points here are, I think it's first of all, understanding where the indicators have to be, and understanding how to reason about the security, and understanding how to think about what you're trying to say from in these records about what I want the recursive to do and what kind of authentication I support. And I think the exact mechanics of how it's spelled, I don't actually care very much about it. I don't think my collaborators I know had a lot to do with SVCB, so I imagine they think SVCB is the right answer. But if it turns out not to be the right answer, I don't think it's going to make us cry. But I think that the key point is that the data flow architecture is what's important. So I'm done now. Oh, I'm sorry, I'm not done. Ha. Let me just finish what I was going to say. So I think there are three contentious issues here. This Dane versus Web PKI, this dot versus DO issue, and our position on both is like, what is why take a position? We have plenty of ways to indicate this. Let the market sort it out. I think it would probably be better if we knew for answer for one of them was like definitely better. Like maybe we would choose, but like there's no particular reason to, given that we have ways to indicate both and we can negotiate them. Now I'm done.
Thanks, Eric. All right, so I think what we want to do now is we've got roughly 20, 25 minutes, and what Tim and I would like to see is discussions over both of these drafts and how they relate to what the working group wants to do and how we want to go forward. So with that, I'm going to open the queue up. First up is Kirsty Payne.
Hi, thank you. Yeah, it's just some clarifying questions actually on the presentation I just saw. So could you just go back a couple of slides? I think it's called like How Security Works or something is the title of the slide. Thank you. Yeah, so I just want to like kind of clarify here. You've got a couple of things where like the connection is secure if something's okay, it's like sent over TLS or signed by DNSSEC. And just to make clear that those provide different security properties, obviously, so I wouldn't want to like bundle them in together. And then just going right back to, I think maybe like one of the first slides, you talked about the threat model and talking about how you would include certain groups of attackers, but not others. I think you said, considering a passive attacker between recursive and some authoritatives is worth considering, but not here. So I guess just a question like, how do you make that value judgment? What is the threat model that you're working to, and how, or like, where would you consider that if not here? And what security do you lose by not considering that attacker? So just a couple of questions really about the security and the threat model. Thanks.
Sure. So it may taking the second first. So that's that attacker is a strictly weaker attacker than the attacker we're considering. So I think what you're losing is there might be some things which will work against that attacker, but not others. So as a concrete example, like I argued that you needed to have security between both the recursive and the parent and the recursive and the child. But if for some reason the attacker could not interfere with your connection between the recursive and the parent and was not on path for that, but was on path between the recursive and the child, then you like wouldn't need a TLS connection with the recursive and the parent because they'd be off path. But I think like trying to figure out who's in that situation is like super hard to reason about. So I just don't think it's worth it. You're absolutely right that DNSSEC and TLS are providing different values here. This is what I was saying earlier about the sort of confusion about like exactly what you're trying to achieve. But for the I'm not primarily interested in this discussion about providing integrity for like any records other than, or data origin authentication for any records other than the ones required to get TLS going. So I assume that the properties you get are whatever properties you get, and DNSSEC is providing or not providing security for all the records. But for the purposes of authenticating the NS record and the SVCB, then like TLS and NS and DNSSEC are like roughly equivalent in this setting.
Ben.
Okay, 2 points. One, I said this in chat. I think this is really about the first draft of the two. What's missing from that draft, in my view, and what we had in the previous iteration, was a way for authoritative servers to get some traffic on a new protocol without guaranteeing that that protocol has uptime. It's the full uptime of the service. The current draft, as I understand it, makes the choice between authenticated and unauthenticated a choice of the resolver, which means that there's no safe way for an authoritative to deploy a new protocol in public, get some traffic on it, get it tested before they give it their full SLA. Okay, point 2. Requirements drafting is really hard. I think this discussion really points to the difficulty of formulating a requirements draft that gets to what we need. For example, do we need to figure out, is it a requirement not to require changes to the EPP specifications and ICANN registry agreements and all of that stuff? I think that's a real puzzle. And the third point is, I think there is a path forward here that sort of blends a lot of the ideas that have been coming in. Roughly, I think it looks like we use some kind of DS hack to encode just a flag that says this child is playing this new game. You know, go ask the child for an SVCB record to find out what you're supposed to do. And that's opt-in. It costs latency, but only for the zones that opt in to play the game. And then eventually we get out of that extra latency by putting SVCB records in the parent and having the parents also do TLS, or in the case of the root, zone MD, zone digest. That also only works for out of bailiwick name servers. But I think that sort of lays out a roadmap where people can start getting protected now or soon, and in the very long term, we can remove the performance cost to make that more attractive.
All right, thanks, Ben. I believe Peter's in the queue to respond to your first point.
Actually, this is Paul. Peter and I have been chatting in the back, so I'll take it. So Ben, thank you. Yes, we on your first point, we totally missed that, and of course it should be added. The ability to do this incrementally is hugely important. And so yeah, and again, we're in the very early stage. Please don't think that if we didn't include something it's because it's not important. It certainly is. On the general point of adding records to the additional section in the parent, I think that that's going to be a real issue. And we on the opportunistic side don't really care how it comes out. We're happy to follow whatever the working group does on that. Whether, and it may be, as Ben just said, we don't do it at all. We do it as a DS or whatever. But to be clear, doing anything, adding anything to the, the additional section takes not only, unfortunately, contract and stuff like that, it also takes updated software. A lot of authoritative software isn't prepared to add willy-nilly to the additional section. But having said that, and I said this in the chat, I believe if that's the way we want to go, we should go that way. We shouldn't go like, oh, it's impossible, well, this will never happen. I think getting this kind of encryption is important, regardless of if it takes a while, and giving up now is silly. And on that last point is, just to be clear, what Peter said in the second slide is, since we do have one working group document now, where we slammed one idea of fully authenticated in, and now Ecker has a much more full explanation, including a use case. We're totally happy to split it out again. And I would, it's up to the chairs, but my recommendation to the working group is that we actually work on these two in parallel and not jam them into one document, even though it would be easier for implementers if we only had one document. It looks to me like the two documents are going to move at different speeds. So however the working group wants to go on that, that's just fine. Thanks.
Thanks, Paul. Daniel. DKG. If you're talking, we can't hear you. There you go.
There we go. Sorry about that. That's probably too loud. Can you hear me now? Apologies.
Yes, we can.
I wanted to follow up on what Ben and Paul were talking about how we get to the deployment phase. If the signaling is a hard fail, so that's a problem. This requires more thinking about how, like, what if signaling is not a Boolean, and I don't believe it should be, because people will be scared to deploy it, then we're going to need to think clearly about what that intermediate state is. In other systems, it's often a report-only state, but then that requires a reporting format and a reporting mechanism, so people can learn, when there have been failures and figure out what the failures are. We see this in MTA STS and a bunch of other situations. We've kind of glossed over that in these two pieces. I actually think it's a significant amount of engineering work, and I want to make sure that we keep that on the table, because if we don't offer an intermediate option between no signaling and signaling means hard fail, I can't imagine anyone turning it on.
All right, thanks. Next up is Puneet.
Hi, can you hear me?
Yes, we can.
Hi, this is Puneet here from Google, speaking more from the Google public DNS position. So I agree with DKG. I was going to make the point that we do need the transitional support for resolvers to be able to move from doing no auth DOT to doing partial auth DOT, right? Opportunistic, or however we define it. And one of the things, as I listen to the presentations, I think I don't see much of a conflict between the first document and the one that EKR presented. I see the one which EKR presented as more defining the signaling protocol and how you get there, like all the information needed to do secure transport, while the first one is more focused on the recursive. So I think if we look at it that way, I don't see overlaps there. The Paul and Peter Van Dyke's document should really lay out the user profiles or the authentication profiles one a recursive resolver could use to connect. And yeah, that's all right now.
All right, thank you. Robert Evans.
Hi, this is Robert Evans. I'm from Google, and I'm the tech lead of Google Cloud DNS. So here on behalf of the authoritative server interest, the ADOCS proposal that Eric is working on is very interesting to me, and I have been focusing primarily on the authenticated case, and I wanted to point out that the idea is for there to be a number of paths to security. The incremental adoption of SVCB-based TLS negotiation provides a road to security, and if the elements, if we can go back to the slide that had the security, there's 3 points there that are important, which is that if the TLS certificate checks out and the NS record set is validatable and you have a secure signal of SVCB, then that makes a secure connection. How we get to achieving all three of those elements could vary. It could begin with a DS signal in the parent, or it could begin with doing a DO53 query for SVCB, et cetera, et cetera, et cetera. Over time, as more elements are adopted or future drafts provide for paths like a DS record that has a specific format, or a parent SVCB with all the appropriate proposals adopted by the right folks, then the security increases. So the last point I want to make is we can have fully secure, from an integrity point of view, SVCB negotiated TLS connections today without parents, as long as there is DNSSEC signatures for the NS RR set and the SVCB RR set at the name server zone.
Thanks, Robert. Jim?
Thanks, Brian. I'm a little bit concerned of the discussion we've been having over the last few minutes. We seem to be looking more at solutions, and I think that might be a little bit premature because I'm not sure we've had a proper discussion of the risk and threat analysis. I mean, have we got a clear understanding of the threat models and what needs to be done about them before we start talking about solutions? I think we might be jumping ahead of ourselves here a little bit.
Thanks, Jim. And I believe that's going to play into some of the discussions that we have on a mailing list about the the quote unquote requirements document, and does it need to have some kind of threat analysis to back up the rationale for the items that we put in there.
Yeah, Brian, I mean, I think some of the stuff that's in the EDOT operational considerations draft isn't really all that well aligned with what we've been discussing today.
Okay. Paul.
Hi, just since a couple of people in the last couple of mic comments have said we might need some way of reporting, especially like if a authoritative server somehow is a signal saying, I do this, and then they actually don't. I just pasted a link in the chat for a draft that'll be being presented at DNSOP, I guess that's 2 days from now. That's not yet adopted by DNSOP, but I think it will be of interest. That specifically is for general reporting from recursive to authoritative. And even though the use case in that document is mostly about DNSSEC failures, it certainly could be used here as well. So I'm not as concerned about a reporting mechanism. And I'm certainly not concerned that we would need our own reporting mechanism. I think a generalized reporting mechanism should be assumed once we work on it a bit. Thanks.
Thanks, Paul. Chris?
Yeah, thanks. I just wanted to follow up on Jim's comment and say, yes, totally agree that it's important to nail down the threat model and make sure that we're solving the right problems. And as an authoritative server, we're interested in like figuring out what that threat model is in particular, and also sort of figuring out what are viable solutions within that threat model. Do not care whether or not it's SVCB or whatever. As Eric was saying during the presentation, we just want to see this problem solved.
Thanks, Chris. Eric?
I mean, I certainly agree that it's important to understand the threat model and the requirements, which is why I started with that in my presentation. We tried to lay that out in our document at the beginning, which is not to say we did so successfully. I guess I'd be interested in seeing, in some forum, which again, up to the discretion of the chairs, some way to workshop that to get to the point where we have agreement that we have the right threat model. And if our test can be helpful there, that would be, of course, great. So I guess my question is, I don't know. I personally am not quite sure what else needs to be done on the threat model. If someone else to weigh in, that'd be great.
So just from my own opinion, Eric, I just want to make sure that the other people in the working group agree on the model that you laid out, and if not, what modifications do they expect or want to see?
Yes, definitely.
All right. Ben
Schwartz. I agree with the threat model on Ecker's first slide. I do think that we should be clear that our aspiration is to solve the whole thing, and that we are going to produce some solutions that solve only part of it. That essentially matching the weaker threat models that Ecker also mentioned.
Thanks, Ben. All right, I don't see anybody else in the queue, so I'm going to ask Tim to run through the action items that he's been able to recover from the meeting, and maybe we can get some corrections on these if people see anything that's missing.
Yeah, sorry. Thanks, Brian. The three that I had was recommendations for the authors on the requirements document via Scott. More interest in the Oblivious Http work with the working group on adopting or not. I think we're going to take some of that to the mailing list, and work with the Peter and Paul on facilitating new edits for their opportunistic draft. I think that's everything. If I missed something, please yell. Paul's ready to yell.
I prefer not to yell. There's somebody sleeping in the other room. It's still before 6 o'clock here. I think a question for a next step is, where do the requirements get specified? So Tim, you had that as like we need to work on the requirements draft, but it could either be that there is the unauthenticated draft talking about its requirements and the fully authenticated draft talking about its, or they go into the requirements document. The worst possible case is that there's 3 documents talking about requirements.
Yes, agreed.
So the chair should figure that one out as to where it goes. I'll speak for Peter here. We're happy to throw our requirements over to the requirements document as long as that document's going to get worked on, which it hasn't been lately. On the other hand, I think that it would be better to have them in that document, next to the fully authenticated ones.
Yes, I think it's good to put them all in one place. Brian and I weren't sure if, like, even if we did a lot of work on the requirements document, if it would ever get published rather than just be a working group document, right? So that was still something we were sort of chewing on. But I agree with you on your points there. So that's something we will have to take back. But mostly what we're trying to do is get more feedback from the working group, per Scott's note, on helping them try to figure out where to go with that. And the queue vanished.
The queue vanished. Any other comments on Tim's list of action items? I think the one thing that I was curious about, and maybe Eric's going to talk in, is adopting the document that he talked about today. Is that what you're asking, Eric?
I mean, I'd be fine with that. I'm also fine with like not adopting it right away, though. I guess I'd like to understand. I guess more importantly, more importantly than exactly what documents get adopted, I'd like to understand how we're going to move forward. And in particular, I don't want to spend the next 9 years workshopping requirements. I want to get solutions. And so I'd like to understand what we need to do in order to get to solutions, and then and then what documents we're going to use to start with those. And so if people think that I guess what I would say is, if people think the requirements laid out in our document are roughly suitable, and that the solution is in vaguely the right shape, then we should probably adopt that and go forward. And if they think that those are wrong, then let's understand what would be right.
Yeah. Yes, and I think I don't want to workshop requirements forever either. I think that's a very good point. I don't think the working group does either. But so thank you.
All right, so do we have any other last minute comments in the 2 minutes and 3 seconds that we have? Okay, so what Tim and I will do, we'll go back, we'll have some discussions on how to drive those requirements discussions within the working group, and we'll get the other action items kicked off. If there are no other comments, we'll give you a little bit over a minute back so that you can prep for your next session. Thanks all for participating, and enjoy the rest of your week.
Yeah, thank you guys. Thank you all.